Okay, we're in section 19 of the notes. We're going to go through the examples now. Again, this is after having a lecture. We're going to go through examples. After lecture and examples, you are to do homework. That is, you need to study the material that we're presenting to you. All right. So I'm going to go to the whiteboard. Give me a moment to do so. All right, you're seeing my whiteboard now. And what I want to do is I want to do each problem separately, one at a time. All right. I realize for some students this goes incredibly quickly, but the bottom line is you can always come back and watch these things at a later time if you want. So if I were doing number one, what I would do for number one is just simply rewrite it first. That's what I would do. So how would I rewrite this? I'd write it as 1 plus the natural log of x to the minus 1. And if I were to take that guy's derivative, dy dx, that would be minus 1 times, I'm using the chain rule, natural log of x minus 2, so sorry about that, times the derivative of the inside. Well, we just discussed that. The derivative of natural log is going to be 1 over x, and derivative of 1 is 0, so that's 1 over x. I would accept this as an answer, by the way, in the exams, but it doesn't look right. And what do you get over here? It would actually be minus 1 over x, 1 plus the natural log of x squared. All right, that's the answer that's listed over here. All right, let's do the next question. The next question is doing the limit. Again, I'm going to say that for some students, they have better reasoning skills than others, and some people can answer this question without doing any work. I want to encourage work, though, because a lot of times you think you know what you're doing when you don't know what you're doing. And always people saying, what's the least amount of work I can do to get credit? Try to do something, all right? So limit, and I'm going to review what you did in Math 119, not with limit problems, but with logs. And this is going to be the log of a quotient, all right? So natural log of 2 plus x over 1 minus x. These are things you learn in Math 119 about logs. It's important you can retain that. However, I want to point out, if you can't retain that, you come by during office hours, and I could actually tell you where you could review this, including watching videos of Math 119 lectures if you need to do that, right? There's nothing wrong with that if you need to review. All right, so what's it going to be? I'm going to write this down, natural log, and I'm going to go to the inside, limit, x goes to infinity. And what do you get over there? 2 plus x over 1 minus x. Did I write that down wrong? I'm sorry, this is plus x. I was going to say that's going to be a tough problem. What do you get over there? Natural log. Well, what's the limit of the inside there? If you looked at it, the limit of that would be 1. Yep, it would be 1. What's natural log of 1? It's 0. And why is that? E to the 0 is 1. Let's go back over here and just verify that. We did it right. All right, this one is a domain range problem. It's actually a 119 question. And again, why are we giving you 119 questions? Just to review it. So kind of a mixture of calculus with 119. All right. So domain of this guy. Let's write this down. Y equals the natural log e to the x minus 2. Well, I know the argument e to the x minus 2 must be greater than 0. So I have to solve that inequality. Where'd you learn about inequalities? Certainly in Math 119. So e to the x greater than 2, which means x is greater than the natural log of 2. All right, so what's the domain over here? I'll write it down for you. The domain starts at the natural log of 2, and it goes off to infinity. All right, let's see if we got that right. And they got it right over here. It's right there. The next question is, what's the range of it? Now, I would recommend just a rough picture of it, and it's at an asymptote at ln2. And what do you get there? Well, the logs look like this. So what's the range of that? The range, which you learned in Math 119, is all real numbers. You can also write that as an interval, minus infinity to infinity. So if we got that, and I'm seeing it. Let's go to number 4. And number 4 says, find a derivative of that. Now, granted, you're free to choose any way you want to do it. So I'm going to basically do it the way I like doing it, but I do want to say there's 2 options in the problem, right? So one thing you could do is do what you learned in Math 119. Let me write that down. So y equals a natural log And that's going to be x4 plus the natural log of sine squared x. All right. Now, by the way, they're not asking for domain. They're not asking for range. They're asking for the derivative. All right. So, my question is, what's a derivative? I got to write this down. So this is going to be y equals 4 ln x plus 2 ln sine x. I'm just using things I've learned in math 119. Now I'm going to take the derivative. So dy dx would equal 4 times the derivative of natural log, which is 1 over x, plus 2 times the natural log, the derivative of natural log is 1 over its argument. Now I've got the inside derivative of sine is cosine, right? So what do you have here? 4 over x plus 2. Well, cosine over sine is cotangent. All right, getting the answer. Now I want to point out, some students say, I don't want to do it that way. I want to do it differently. We're not telling you you can't do it differently. I just want to do it differently as well. All right. So I got to be prepared when I'm grading an exam to see all kinds of different things. And let's do this. Well, some students might say, oh, it's 1 over its argument. Nothing wrong with that. Now times the derivative of the argument. And that's going to be, let's see, x4 times 2 sine x cosine x. Oh boy, I got to keep going, right? Plus 4x cubed, right? 4x cubed times sine squared. Again, if that was an exam question, I would give full credit for it. I got to go back over what I wrote down, though. I wrote that over there. I'm thinking my answer is a lot simpler. And I want to go through it with you, though. All right. And one step at a time, by the way. I want to see if they're equivalent answers. Let's multiply it out. What do you get? x4, 2 sine x cosine x over x4 sine squared x. Hope I didn't go too fast with that. Plus 4 x cubed sine squared x over x4 sine squared x. And again, I'm not beyond making a mistake. I'm going to look at this and simplify. This simplifies. Well, one of the factors of sine disappears. And what he left off over there, 2 cotangent. All right, that part's done. Let's do the next one. What happens there? This cancels. Oh, no, it doesn't cancel. I get 1 over x. And this would cancel, though. So I get x there. So what do you get? Plus 4 over x. Is it equivalent? Let's take a look. Maybe I made a mistake. Wow, miracle. It's equivalent statement. Okay, let's do the next one, number 5. And number 5 is a limit problem. All right, so we're certainly doing calculus. And to do that, I want to recommend there's many ways to do it. And one way to do it is just simply look at the domain of the problem. And this is log base 10. I'll write that down for you. And this is y. And I'll put the domain down for you. And part of the domain is, I'm going to say, x squared minus 5x plus 6 must be greater than 0. And this would be x and x. I'm going to say 3 and 2 minus minus. So I get, what do I get there? That right? Yeah, that's right. So I get 2 and 3. Take a number to the right of 3, like 5, plug it in. It would be positive. That's certainly greater than 0. Take a number between 2 and 3, like 2.5. It would be negative. I would not plug that in. Where'd you learn how to do this in Math 119? It's actually the very first lecture in Math 119. Take a number like 0, plug it in, which is the left of 2. It would be negative times a negative, which is a positive. So I know the limits in the proper place. And what I mean by that is just kind of looking at this, I know I can approach 3 from the right side. I know that. So let's take a look at it. And I'll write down the limit now. And the limit is going to be x goes to 3 from the right side. And this could be log base 10 of x squared minus 5x plus 6. So what I'm going to claim over here is that really what we're doing is the argument when I approach 3 from the right is approaching 0 through positive numbers. So this over here is actually approaching 0 from positive numbers, right? Now, I hope you realize when you're looking at a log looks like this over here. And when you approach 0 from the positive numbers, this would go off to plus infinity. All right, that's the limit of it. I'm sorry, I said plus infinity. I'm looking directly at the picture. This is going not to plus infinity, and I apologize for that. Where's it going? It's going to minus infinity. I got to get my eraser out. Maybe I'm daydreaming too much. Let me erase that. Okay. All right, let's do the next one. And when I do the next problem, again, a lot of people says, I don't want to do what you're asking me to do. Not that you should never feel like you obligate to do what you're being asked to do. Now, certainly you're in school, you get credit for doing what we ask you to do, but you may decide you want to do things differently. I don't mind that. I actually encourage it. All right, let's write down what they said to do. Take natural log of both sides and expand the right side completely. Well, let me write that down for you. That would be the natural log of y, I can do that, equals the natural log, let's write this down, root x times e to the x squared times x squared plus 1 to the 10th power. Now what they said, expand the right side completely. Now some people that misunderstand that, and what they're going to do is, well, part of the reason they misunderstand, they really haven't had the necessary background in pre-calculus. They actually expand x squared plus 1 to the 10th power. That would give you 11 terms. That to me would be kind of crazy though. So I'm going to just use what I know about logs. Well, this is the section on logs. So what's it going to be? Well, it's going to be the natural log of the root of x plus, this is a product by the way, the natural log of e to the x squared plus the natural log of x squared plus 1 to the 10th power. So I did that. I did the expansion. Is it completely done? No. In 119, they made you really go pretty far out in the expansions if you could. So the natural log of x, the root of x is really x and a half. So it's 1/2 natural log of x. This one's going to be plus the exponent comes down. That's x squared times, what's the natural log of e? It's 1 plus, this would be 10 natural log x squared plus 1. And this could be natural log of y. So did we expand the right side completely? I think so. Let's take a look at their answer and see how we did. So I'm seeing the natural log of 1/2 ln x. I'm seeing the x squared. I put x squared times 1, still x squared. And I see this. Now what did I say? Differentiate both sides. I can do that. What's the derivative of, and again, we're differentiating both sides now. That's going to be 1 over y dy dx equals, well, it's going to be 1/2. What's the derivative of natural log? X on the bottom plus 2x plus 10 over, derivative of natural log is x squared plus 1 on the bottom, and chain rule times 2x. Let's see if we got that answer. All right, so we got the left side, right? We got 1 over 2x. This is 2x. Now they wrote down 20x. I do see that, by the way. I do prefer the 20x to what I wrote down, but I'm not saying it's wrong. Now what are they going to ask me to do? They're going to ask me to find y prime. Let me write that down for you now. So dy dx, which is y prime, is going to be y times 1 over 2x plus 2x plus 20x over x squared plus 1. I want to be honest with you, this is a little strange to me. I'll tell you why. Dy dx, I'm supposed to have a function in terms of x's, and I'm looking at that y and it disturbs me. Do I know what the y is? And I do. It's in the beginning of the problem. So let's write this down. Dy dx. What's y? It's root x e to the x squared plus 1 to the 10th. That's what y is, by the way, times this guy over here. And that's the answer, by the way. By the way, I'm going to look at the answer later. Somebody said, I don't like what you did. I want to do it differently. So what you could try, and we want to recommend you do try to differentiate this without using logs. You're going to see how difficult it is, how utterly difficult that is. But you could, and if you did it all the work, when the dust settles, you're going to get the same answer I get over here, provided there's no errors being made. All right, so what I want to do is I'm going to next page. I want to see if I got the right answer. I'll look at this guy over here, pull it aside. And the reason we're showing you this is we're trying to encourage you to do this too. This is what he tried to encourage me to do. Be critical. Look at this and see if you got the right answer. So I'm going to put this over here. I'm going to get my red pen out. And I'm going to look at it, see if I got the right answer. Well, I get the root x. I got e to the x squared plus 1 to the 10th power, 1 over 2x. Yep, I'm getting the same answer, which is great news. All right, let's go to the next question. Next question again, I'm looking at it. Actually, this question was lifted directly from my mth121 notes. And I want to see if I can do the domain now. What's the domain? It's a function, right? It's e to the x. It's really not that bad. So let's write this down. So I know that, e to the x, the domain is orbital numbers, but the bottom presents trouble for me. Is the bottom ever equal to 0? Let me write this down. So is the bottom ever equal to 0? Well, what does this mean? It would mean 1 equals e to the x. And yeah, it does. If x is 0, the bottom would be 0. So I'm going to say all the real numbers. However, x can't be 0. And why is that? The bottom becomes 0. What do you see that? You see the answer over here. If you want to write down interval notation, it would be minus infinity up to 0, union 0 to infinity. All right, that's done. All right, next one is range. Range is it's much more difficult. And we know that to be true, by the way. So I'm going to say this over here is that this might be really tough to do from a 1/19th perspective. But I'm going to, maybe write this down for you. And it's tough, though. I'm not saying otherwise. So f of x. I'm going to draw like a crappy picture of it. So I know it's 0. It's not defined. So really what I'm going to do is I'm going to talk a little bit about limits in the problem over here. So I'm going to take the limit as x approaches 0 from the right side. All right. So if you did that, now I'm not saying it's going to be easy for you. We're looking at f of x. And I want to point out we're approaching 0 from the right side. Well, the top is really easy. When you approach it from the right side, the top would just be 2. Right? That's not a problem for me. It's the bottom that's trouble for me. And what do you get? You would get 1 minus e raised to the power 0. But I hope you start to realize that if you were to do that, you're actually to the right of 0. So that number e to the 0 to the right of it would be a number bigger than 1. So the bottom's negative, but it's getting close to 0. So what do I see? I would see 2 over a very tiny negative number. And what does this give me? Minus infinity. So I'm going to say it goes down like this. All right. Now let me look at the other limit. Limit x goes to 0 from the left, f of x, and wonder where that goes. Well, on top, when you get close to 0 from the left, it would get close to 2. And the bottom, what are you getting? A number smaller than 0, like a negative number. And so I'm going to say, well, it does get close to 0, right? I know that much. But I hope you realize we're getting, a number. Let's take a look at that. It's going to be, what would that be? I get a little negative number there, right? So it's going to be a number that's, slightly smaller than 1. So it's 1 minus a number slightly smaller than 1. I'm going to get a positive number. So I can say it goes off to plus infinity. All right. So the next question is like, what happens in between? I don't know. I guess I should take a look at limit as x goes towards infinity. Right? And what would you get over there? If you go towards infinity, I guess I would divide through by e to the x, right? And that would be 1 over e to the x plus 1, 1 over e to the x minus 1. And those terms over there, when we go to infinity, would be 1 over ex goes to 0. So the top would be 1, the bottom would be minus 1. So I'm getting an asymptote at minus 1. Let me do the limit as x goes to infinity minus infinity. I'll put this one over here. So 1 over e to the x, 1 plus e to the x. I'll do it in stages. Yes, we know it's difficult. Yes, we're trying to encourage you to do work. Divided by e to the x, 1 over e to the x plus 1. And what do you get over here? Let's see, you'd get 1 over e to the x minus 1. I'm sorry, that's plus x. Did I do a mistake here? Yeah, I didn't do any mistakes. What do you get there? Minus 1. So what do I know? Oh, geez. I got this, and I got something like this over here. All right. So let me, I'm going to do another. I'm going to figure out where this thing takes on its 0 over here. Just for curiosity. And I'm going to, it occurs when 1 plus e to the x equals 0. So e to the x would equal minus 1. I think I made a mistake in my graph, by the way, and I hate to admit it. So I got to stop and I got to say I made a mistake somewhere. And I know I made a mistake. And I'll tell you why. I'm not getting that. There are no zeros in the problem. So let me make sure that. Yeah, I made a mistake. I got to start again. I apologize. Let me erase. Let me erase all this business over here. And it's going to happen decently. You're going to say, oh, geez, why did that happen? I don't know. Range is always difficult. And there's a point to this, by the way. And I'll tell you why there's a point to it. Finding the inverse would make it so much easier for me to find the range of the problem. Let me see if I can erase that. You know, I don't think I can erase it. Yeah, there it goes. Erase this over here. All right. I made a mistake. Oh, you know what? I didn't make a mistake. I made a mistake only in one part of it. Only in one part. Let me go over it again, though. So f of x again, I know I got an asymptote at the 0. And let me go through those limits again too. Limit x goes to 0 from the right, f of x. Let me think again. If you go to 0 from the right, I'm on the right side of the 0. And again, I know the domain has a 0 in it. That's a problematic number. You get 2 on the top, 0 from the right. You can get negative about minus infinity. So I still get that. Limit x goes to 0 from the left, f of x. What do you get at the top? You still get 2 on top. Let's see, you got negative numbers on the bottom over there. So that would be positive plus infinity. So I'll put this over here. And then the limit, x goes to infinity, 1 plus e to the x over 1 minus e to the x. That's minus 1. Make sure I said that right. Yeah, minus 1. So I get this over here. And now I'm going to do limit as x goes to minus infinity. And this is where I made a mistake last time. Maybe I was daydreaming. Maybe I wasn't thinking, who knows? And what's this limit over here? I divided by e to the x. You don't have to. And the reason for that is e to the minus infinity is 0. So the top is 1 and the bottom is 1. And that limit's 1. And that's where I made my mistake. And this is going to be y equals 1. And this is y equals minus 1. So I'm going to say that, you know, a lot of work and mistakes can be made. I think I got the domain of it now, right? That was pretty easy. And now I got the range of it. What's the range? My little hokey picture, minus infinity up to -1, union 1 to infinity. That's right over there. That was work though. And there's a point to this. I even made a mistake in my initial work. I had to do it over again. And there's a point to it. And the point to it is that sometimes, getting range can be really, really, really difficult. All right. So what does it say? It says find F inverse now. And this is the whole point. You remember back in Math 119, when you found the inverse, domain becomes range, range becomes domain. Maybe this will be easier for me to do. So what did they tell you to do in Math 119? They told you to write, y instead of f of x, 1 plus e to the x over 1 minus e to the x. Then they told you to change x and y. Let me write that down for you. Again, I'm trying to find the inverse. The way we did in 119, though. Oh boy, I got work to here, don't I do? So it's going to be x minus x e to the y equals 1 plus e to the y. I'm going to try to get the y's on the one side right away. So it's x minus 1. That's going to be x e to the y plus e to the y, x minus 1, e to the y, x plus 1, x minus 1 over x plus 1, e to the y. Well, when's this going to end? Oh, now y is the natural log of x minus 1 over x plus 1. All right, so let's go back over here. Let's make sure we have that written down. The inverse I now know is this right over here. I know the inverse. I just found it. Now, someone could say, what do you need to do? Also specify its domain and range. Well, I kind of did that. So I know if this is the domain, that would be the range of that. So the range is going to be the same thing as this. And the domain of this will be the range of that. But remember how much trouble I had finding that range? So I'm going to do this over here. What do I know about natural log? So I know the natural log, this is the inverse, by the way, x minus 1 over x plus 1. This might be an easier problem to do. And what am I going to say? X minus 1 over x plus 1 is greater than 0. This is going to be easy for me to do. Why is that? It really reflects nicely on what I learned in Math 119. So put this down, minus 1 and 1. You're going to take test values here. A number after 1 would be like 2. Plug it in, you get positive. Again, I'm solving a very simple inequality. A number below minus 1, like minus 2, plug it in, you get negative of a negative, which would be positive. So what's this guy going to be? Minus infinity up to minus 1, union 1 to infinity. This was so much easier than me graphing. I hope you can appreciate that. All right, hope you can appreciate that. All right, let's go to the next page. Next page, they graphed it. I'm going to say use technology to graph it. Graphing's tough, but I will want to point out what you learned in Math 119. You put a line of symmetry in, and that line is y equals x. They kind of ask you to do that when you're doing inverses. I want to claim that I did use technology to do this. And what I did was I graphed out in blue the graph of f of x, that's in blue. I want to point out where that is for you. That's written right over here. F of x in blue. The red dashed line is just simply y equals x. And I graphed out this one in green. What's its inverse? What is it? It's a rotation about the line y equals x. Again, technology does help a great deal in being able to visualize that. All right, next up is going to be a question. A lot of people put down wrong answers, but at least they do it quickly. I will say that. But they want me to find the derivative. So what I'm going to do is, this section's on logs, and I got to tell you, logs make problems easier for me to deal with. So what do you say? You get x to the y is equal y to the x. These are, generally speaking, very difficult questions to do unless you know how to deal with logs. So I'm going to take the log of both sides. And what are you going to get? Y ln x equals x ln y. I know this is difficult, by the way, but I want to go through it. All right. Someone says, why is this difficult? Because it looks foreign to me. So I'm going to take a derivative of the left side. And the derivative of the left side basically is y times the natural log of x. So let's see if we can put that down. So the first function y times the derivative of the natural log of x, which is 1 over x, plus the derivative of y, which I know to be y prime or dy dx, times the natural log of x, equals, well, let's do the other side. It's a product again, right? So we're going to say x times the derivative of natural log of y. Well, that'll be 1 over y. Go to the inside, which derivative of y? It's y prime. Yep, I know it's tough. Plus, practice is going to get better at this, by the way. The derivative of x, which is 1, times the natural log of y. All right? It's tough. And by the way, we'll get to another section of the notes where we'll do this quite often. It's what's known as implicit differentiation. So what do I got to do? I got to simplify it, and you get y over x. And this is going to be plus y prime ln x. This is going to be, let's see, x over y, y prime plus ln y. Well, I got to solve for y prime. And how do I do that? There's a variety of ways of doing it. I'm not saying one way is better than the other, but I'm going to put down y prime ln x minus x over y, y prime equals ln y minus y over x. What I do, I got the y primes on one side, everything else that didn't have y prime in it. I'm going to factor out y prime. And we left off with ln x minus x over y is equal to ln y minus y over x. I got to solve for y prime. We'll look at the key later. Y prime, same thing as dy dx, by the way, is equal to ln y minus y over x over ln x minus x over y. I realize what someone's going to say. Oh, I'll memorize that guy because it's just too much work. I get the answer here. Someone says, what do they do next? Well, let's go through that. It looks like they multiply top and bottom by xy. And what would they end up with? xy ln y minus y squared. What do they get in bottom? xy ln x minus x squared. All right. Now, someone says that they still didn't write that down. They multiply top bottom by -1 because it looks better to them. Again, that what looks better to them is the polynomials versus that a transcendental function of natural logs. That's how they get over there. Either one's fine by me. Okay, here's your problem. So you see me go through a bunch of examples through lecture. Yeah, we spend time on it. And you got to spend time on it. I mean, you got to spend time on the study department. You study what we've given you. Sorry. And then applying what you studied, can you do these problems? Do problems. There's also an additional, for most teachers, an additional WebAssign component. Do the WebAssign. Thank you.